So we've seen if statements and if-else statements and elif statements, and we saw the conditionals or Boolean expressions and the comparison operators that let us build up basic conditionals. If we want to express more complex conditions, that is to say things that take into account more than one comparison in a single expression, then we need to use what are known as logic operators. The three basic operators are not, and or. These let us ask more complicated questions that are combinations of Boolean values. Somewhat like arithmetic, but for Booleans. So we have Boolean in and Boolean out. Starting with the not operator, negation formally, this takes its input, which is a Boolean value, and flips the truth of it. So not true becomes false. Not false becomes true. It's a very simple statement. In English, we could say, if I am not sleepy, then I will study. If it's not snowing, then I'll bike. If it's not warm outside, then I'll bring a coat. Next up is the logical AND operation. So AND, formerly known as conjunction, combines two Boolean inputs, and its output is true only in the situation where both of its inputs were true. If either of its inputs are false, then the result will be false. So we have a truth table here which shows that. On the left you have one input, on the top the other input, and the intersection is the result of the AND operation. So notice only where both inputs are true is the output true. In all other cases, the output is false. In English, we could say, if I am hungry and I have $20, I will buy pizza. Notice that both of those things need to be true. If I'm not hungry, then there's no need to buy pizza. If I am hungry but I can't afford it, then I still will not buy that pizza. It only happens if I have the motivation and the means. Alternatively, I could say, if I am buying a movie ticket and I'm a student, then I will get the discount on the price. Again, both of those need to be true. If I'm not buying a movie ticket, no discount. If I'm not a student, no discount. But if I am a student and I'm buying a ticket, then the discount. And the third main logic operator is known as the OR operation, formerly the disjunction of its inputs. This takes in two Boolean inputs and is true if either of them are true, also if both of them are true. Another way of saying this is it's only false if both of its inputs are false. So looking at the truth table again, we can see the only situation where the OR statement returns a false is when both of its inputs are false. Any true in the input makes a true in the output. In English, we could say, if the car battery is dead or there is no gas, then the car will not start. Right? In either of those situations is enough for the car not to start. Alternatively, I could say, if I'm hungry or I'm bored, then I will check the fridge. Either hunger or boredom are motivation enough for me to check the fridge. If both are true, I will also check the fridge. If neither are true, I'm not hungry and I'm not bored, then I will not check the fridge. It's worth pointing out that the OR statement is a little bit different than in English. In English, the word OR is sometimes used exclusively. So I could say something like, you can have a side salad or fries. This implies one or the other, but not both. In conditionals, when we have an OR statement, OR can be one or the other or both. This is what's known as an inclusive OR. Now, using these logical operators, we can construct complex Boolean expressions just like with arithmetic. We can use a combination of operators to make more complex expressions. And when we evaluate the expressions, we do so piece by piece according to precedence. As an example, here's a Boolean expression, so let's figure out what's the first thing that happens. Now, because there are brackets here, those expressions will have the highest precedence. So going from left to right, we have not false, and the false and true will happen first. So we'll end up with this statement here. Notice the not false became true, false and true became false. Following through with our brackets, we have true and true, which is true. We have true or false, which is also true. So we're left with true and true, resulting in the final answer, true. Try another expression here. Same idea, so we have not true, which happens in a bracket. So we have not true becomes false. Then not false becomes true. We have false and false, which becomes false. Now we're left with true or false and not true. So without brackets, we have all three of our logical operators. In order to resolve this expression, we have to know the precedence rules for these logical operators, and that's as follows. So not will happen before and, which will happen before or. So not has the highest precedence, then and, then or. So in this statement here, the not true will happen first, so we'll have true or false and false. And happens next, so we have false and false. And lastly, we have true or false, which becomes true. Notice you would arrive at a different answer if you did not follow those precedence rules, if you just went from left to right, so it is important to know the precedence rules of these new operators. Considering all of the operations we've seen so far, here is an updated precedence table. So we have brackets at the top, then exponentiation, then we have multiplication, division, and all of those, then addition, subtraction, then we have the comparison operators, all of which happens before, not, and or, and finally the assignment down at the bottom. Again, when in doubt, always use parentheses to make your work clear. All right, let's quickly practice with some examples here. Let's open up Python. And I'll say an expression like 0 does not equal 1, and 1 plus 1 is equal to 2, or true. Now, before typing this in and hitting enter, walk through this expression and see what do you believe the answer to be. Pause the video, and when you return, we can run the code and see. So walking through this, starting with the highest precedence, we have brackets. So inside these brackets, we actually have two operators. We have addition and equality. Addition happens first, so this is 1 plus 1 is 2, and we have 2 equals 2. The question is, does 2 equal 2? So that's true. So then this whole thing is true. We have true or true, which again is true. So then we have 0 is not equal to 1 and true. The comparison 0 does not equal to 1 is also true. So we have true and true, which gives us true. Another example, I could say 7 greater than 2 and 3 greater than 4 or 6 less than 5. So again, starting from our brackets, we have 3 operations inside this bracket. We have 2 comparisons and an OR statement. The comparisons have higher precedence, so we have 3 is greater than 4, which is false, and 6 is less than 5, which is also false. So we have false or false, which is just false. And then we have 7 is greater than 2, which is true. So that becomes true and false, all of which is false. On to the next, we say not 6 plus 1 is greater than 7, or 4 does not equal 3, and true. So starting from the inside of our brackets, we have 6 plus 1 is greater than 7. So 6 plus 1 happens first, 7 is greater than 7, and that's false. Next bracket over here says 4 does not equal 3, that's true. So now this whole bracket asks false or true, which is true. The not of true is false, so now we have false and true, which becomes false. All right, moving on to the next. 4 is less than 3, and 7 times 2 minus 4 times 12 is greater than or equal to 3 times 23 over 8. So we have 2 comparisons here. So all of this is going to be ANDed with all of that, which means if we look at this first one here, we see 4 is less than 3. That's false. So we have false and all of this. And we know when AND has any false in its input, the result is false. So because this is false, means we don't have to consider the result of this component of the expression to know that the entire thing is false. This is what's known as a short circuit evaluation. We don't need to consider the second part of that expression because the first part of the expression denotes that the whole thing will be false. I can also ask 1 plus 2 minus 3 times 4 divided by 5 is greater than or equal to 10, or 3 is less than 4. Again, this is a short circuit operation. For humans at least, the compiler would still have to look at the left-hand side because it comes first, but because we know that 3 is less than 4 is true, and any truth in an OR statement makes the whole thing true, we know that this whole expression will be true. Up next, we have another challenge. So write a program that asks the user for a number between 1 and 10 inclusive. If the user enters a number inside of the range, then we'll thank them. If it's outside of that range, then we'll display an error message. This is a useful snippet for a lot of other programs where we need to sanitize a user's inputs for use within our own program. So let's create a new file in VS Code. I'll call this one input in range.py. And this is a challenge to accept only numbers between 1 and 10 from the user. So our input to this program is going to be a number from the user, then we'll check if that number is in a range. So our comparison needs to do 2 things. It needs to check, is that number greater than or equal to 1? And is that number less than or equal to 10? So for this program, we have to first get an input from the user. So get a number from the user, and then we need to check if that number is in range. Now to check if that number is in range, we need to do 2 separate comparisons. We first need to make sure that it's above the lower bound of that range and below the upper bound. So x is greater than lower bound, which was 1. And we also want to check that x is less than the upper bound, which is 10. Right? If we only check one of those things, then we can still get numbers outside of our range. Right? If we're only checking the lower bound, Then a user could enter 3, which would be accurate, and that would pass our test. Or they could also enter 13, which would still pass our test, but would not match the requirements for this challenge. So let's do this. Let's first get a number from the user. We'll call it x equals input. Enter a number in the range 1, 10 inclusive. And again, for now, we'll assume the user plays nice with respect to actually entering a number and not putting in some silly words in there. So we'll just convert that to an integer so that we can use it as an integer. So if we assume the user enters an integer, but we're not assuming that they enter the correct integer, we now need to check that the number they've entered is in the right range. So we have an if statement for this. Now we could solve this using nested if statements, and I invite you to pause the video and try that out for your own interest. But for this challenge, let's see if we can solve this using a compound Boolean expression. So we have two separate bounds to check, so we have two separate comparisons. First we want to check, is x greater than that lower bound? So we can say x is greater than or equal to 1. And then we have another comparison that x is less than or equal to 10. Now we could say if and have two separate questions and try to figure out a nesting that makes those work, but let's see if we can combine those into a single expression. Now in this case, in order for this condition to be true, we need both the lower and upper bound to be correct. So we want both of those to be true, so we'll say and. Now if either of those is false, the whole thing is false, and if both of them are true, then the number is within the right range. In that case, we'll print thanks, entered a good number, and otherwise we'll print error. Let's test this out. We'll say Python input in range, and we'll enter a number somewhere in the range. We'll say 6, and it says that's good, and we'll enter something outside that range, and it says error. Could put a -6 in there as well. That's outside that range in a different direction. This is also a good idea to always make sure you test the edge cases. So for this case, we'd say, does 1 work? And it should, and it does. And does 10 work? And it should, and it does. So we've tested both of our branches, and we've tested the edge cases of those branches as well. I should also point out, in Python, there is a shorthand for doing this two-sided comparison. So x is greater than or equal to 1 and x is less than 10. We can write this in Python. Let's just give a value of x is 6 here. In Python, we can say 1 is less than or equal to x is less than or equal to 10. And this is true. And if we set x to 65 and ask again, this is false. So this is a shorthand version of doing this. It's a very natural way of expressing both of these comparisons in a single expression. However, as with Python things, there are some oddities. So for example, I could say 2 is less than 3 equals true. And looking at this comparison, you might say 2 is less than 3, which is true. And then you have true equals true, which is also true. And I enter this, and the value is false for some reason. And that seems perhaps odd. The reason is because this is actually two separate comparisons, right? We're first comparing 2 to 3, and we're comparing 3 to true. It's not doing, as you might expect, 2 is less than 3 equals true. That becomes true as we see it. But what this is actually doing when we say 2 is less than 3 equals true is similar to this form here, where it's taking two comparisons and combining them into one expression. So if we expand that out, what it's actually saying is 2 is less than 3 and 3 equals true. Now on the left we have 2 is less than 3, which is true, but on the right we have 3 equals true, which is false. So now if we have true and false, the whole thing is false. So although that shorthand is available, it's good to know that it may cause problems if it's used incorrectly.